Hello and welcome back to yet another Sudoku puzzle. Today we will be going through the Fruity Caverns puzzle, which you can see right here. And the rule for the puzzle today are as follows. Normal Sudoku rules apply. And then we have this yin-yang rule. Shade some cells such that all shaded cells are orthogonally connected, all unshaded cells are orthogonally connected, and no 2 by 2 area is fully shaded or fully unshaded. Now, what does this rule mean in the Sudoku? So let's imagine just a big old line. Just draw it like, uh, let's just make a line here. Not with this one. Yeah, something like that. Let's just imagine that is colored in like that. And then all the remaining should be a different color. And now we can already see here there are some inconsistencies, such as we cannot have any 2 by 2 area be one single color. So for example, this one should have been a different color, and so on and so on. And also that all of the shaded cells, all of the unshaded cells need to be connected to each other. So this little block in here, we can see it's not connected to any of the rest of the green. Same with this one, same with this one. So this is not a possible solution. Yeah. And then let's just go down to the next one with the same shading up here. Digits in circles give the number of cells, including itself, of the same shading as itself, seen in all horizontal and vertical directions. Combine cells of the opposite shading blocks division. So let's look at this little circle up here, for example. It's shaded red. And then we need to figure out how many other reds does it see in the horizontal row and in the vertical column. So for this one, for example, it can see itself and 3 other cells. So this one would be a 4. And this circle here can only see the green, so it will be 1, 2, 3, 4. And then the red over here will block division over to the remaining. So this one would also be a 4. And that is basically the rules for this Sudoku. So let's just get into it, shall we? I guess these two circles up here are pretty interesting. So let's imagine the circle is a red circle. Now what color is this circle gonna be over here? Let's imagine this is also a red circle. Now there's this special little thing about yin yangs, which are we cannot make small sections of shaded and unshaded cells so that they're broken up into parts, because there's no way we can connect these green ones to the green ones down here while also having this red one go over to all of the remaining red ones. So for yin yangs, you will only get like one shading, all orthogonally connected, and then you need to have the unshaded ones be connected to each other in a different pattern. So we cannot have any broken up parts like this, which means for these two up here, if they are both red, they would be connected in some way or another. Either it would be all the way to the bottom down here, going back up, or it would be just straight across in the top. But what does it mean now that these two are connected? Let's remember the rule down here where the circles give the number of shaded or cells shaded with the same shade. So if we're going across the top and connecting these two circles, we will have this one sees 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. Of course, it cannot go down any further because then that would be 10 cells, and that is way too much for a single digit. So this one would be 9. And now this digit over here would also see 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. And that is just impossible based on the normal Stokes rules. You cannot have two 9s in the same row. So we cannot go across the top. And let's just remove this shading again. Now let's see if we go the other way around and connecting the two red cells. Now this circle up here sees 1, 2, 3, 4, 5, 6, 7, 8, 9. This one will be a 9. And the same goes for this circle over here. It also sees 9 shaded cells. Again, we have the two 9s up here, which is not possible. So now we know these two cells are two different shadings in the yin-yang puzzle. Alright. Now this circle down here. What can we say about this one? If this is a red circle, we know it needs to be connected to this red circle. It cannot go through the green one, so we know it will need to go through all the squares over here. Now we have the same issue with these two circles. This one already sees 9 digits. This one already sees 9, or not digits, but shaded cells. So again, we would have this double 9 issue, which means this one can now not be a red one. And the same goes for, not for this digit for now. We know this one needs to be green, so now we can connect these two green shaded cells, because we know they need to be connected at the outside. So this one sees 9 digits now, as we learned from before, which means this one needs to be a red cell now. Which means, same as before, we need to connect the reds together. And now this one sees 8 red shaded cells. But can this one be red now? If this is red, we are seeing 9 red shaded cells, but we already have a 9 in the row, so this one needs to be an 8. And now we know this one is green. We need to connect it down to the other green, so let's shade all of these squares green as well. So now we have a nice border. Now we can shade these two red, because we know any 2x2 area cannot be filled entirely by one shade. So we need to cut it off here. Now this little circle, I guess the circle down here, we know it has to be a 9. It already sees 9 shaded cells. This is 9. This one needs to be red now, because we cannot go any further. We need to block division to the remaining. And this one over here, we already have 8 green shaded cells, but we cannot make it an 8 because of normal Stokes rules. This one needs to be a 9 then, which means this one needs to be green. The next one needs to be red to block division for the rest. Now we have the same rule with the 2x2 areas. These two needs to be not green, red. And same goes for these two digits over here, because of some yin-yang rule. If this one is green, for example, there's no way to, same with the border where we cannot break up any of the connected digits. We cannot have this checkers pattern, because you need to connect this red over here somewhere, and then you need to connect this green to something, but you cannot really connect it down here, and you cannot connect it to anywhere in the cell without blocking off the rest of the red from the remaining ones. So we need both these two cells and these two cells are now red. This one needs to be green because of the 2x2 area in the yin yangs. This one needs to be red now because of the 2x2 area. And again, we cannot have this checker pattern, so this one needs to be red as well. This is green because of 2x2, same for this one. And again, no checker pattern, this one needs to be green. Now we have the circle here, it sees 1, 2, 3, 4. You cannot see anymore in any of the directions, they're blocked off. This one needs to be a 4. Where do we go from here? This one only sees 2 digits. What do we do here? This one, this little circle here, sees 2 digits or 2 shaded cells already, but we already have a 2, so we know it needs to be a higher digit. This one needs to be shaded now. And I guess this one cannot be shaded now, because if this is shaded, let's imagine this is shaded, these 2 digits will always see only the shaded cells in the row, which means they always see the same amount of shaded cells, which is not possible. If this is seeing 3 now, this one is also seeing 3, no matter if we also add the red shade over here. So now we know this one needs to be red. And this one, let's imagine this is red. We know this one cannot be red now because of the 2x2 area. Now we have the same issue where these two see exactly the same amount of digits, only in the row. So this one needs to be green. This one needs to connect to the red in some ways, so it needs to follow up in somewhere. This one needs to be green because if this is red, this one only sees 2 green, and we have the 2 over here, so this green need to push the red up again here. This one sees 3 red digits now, 1, 2, 3. Nothing in the column. This one sees 1, 2, 3, 4. And now this one sees 1, 2, 3, 4. It cannot be a 4, so we know it needs to go somewhere up in the column. Now this cell here, can this be a red? No. Why can it not be a red? This little digit right here, or this little circle, sees 1, 2, 3 of the green shades. We already have a 3 here, so it needs to go higher. This one needs to be green. Now we have the 2x2 area, this is red. And now this one needs to be green as well. We have the same issue. The circle down here sees 1, 2, 3. It needs to have something more. It also needs to have the next one because it sees the 4. So we couldn't have 1, 2, 3, 4 and then the red. Now this square here, what shading does this one needs to be? If this is red, we had the same issue down here where some rows could only see, or some circles could only see the shades in the row. Now this one will have the same issue where these two can only see the shades in the column because both are blocked by the rows, and they will have the same digit, which is not possible. So this one needs to be green. Now we have the 2 by 2, this is red. Now this one over here also needs to be green. This is red. Both of these digits see everything in the row plus 1 extra shade. So they will have the same digit. This is green now. Can this one be red? No. If this is red, this circle sees 3 squares with the same shading. It's already occupied by this 3 in the row. This green. This red needs to be connected to all the other red in some way, so we need to push this one up a bit. What about now? We know this digit in the circle needs to be 5, because 1, 2, 3, 4, 5 shaded that it can see. And this circle here, currently it only sees 5 shaded cells, but we cannot have a 5, so this one needs to be green up here. This is 6, this is a 7, this is an 8. This one here sees 3 shaded cells. This circle here sees 1, 2, 3, 4, 5. We cannot have a 5, so this one needs to be green. Again, this one needs to connect to the other reds. This one also needs to connect to some red anywhere in the yin-yang rules. This one sees 1, 2, 3, 4, 5, 6, or 8. But it already sees an 8, so this is 6, which means this one is green. Now we have this one connected by the red, and then we need to connect it, all of these red up here, either in one of these 2 cells, but not both, because of the 2 by 2 area. So now we know this one sees only 1, 2, 3, 4, 5, 6 shaded cells in green. This one down here sees 1, 2, 3, 4, 5 currently, which is not enough information for now. This one sees 2 or 4. This one sees 4 or 6. And this one sees 3 or 5 if we connect it somehow. And we know this one needs to be a red now, because if this is a green, we have the same issue. But these 2 can only see the same amount of shaded cells, no matter what, because the column's already occupied by the red. So this one needs to be a red. This one is the green. So this one is now 4. This is 2. This is 5. This is 3 shades. This is a 2. Now we need to have a look at some of these circles over here. This one currently see 3 shades, 3 shaded cells in the row. It cannot be a 3 or 4, so we know it needs at least 2 more shaded cells. So now there's a 5, or if this is red, it would be a 7. But 7 is here. This is a red, this is a 5, this is a green cell. This square here can see either 3, 4, or 5. 4 and 5. It cannot be 4 and 5 based on these two squares, so this needs to be a 3, which means this one is green. We cannot have this checker pattern again, so this is a green square. And now for this one maybe? 1, 2, 3, 4, 5, or a 6. So I guess we can also just look at this one. It needs to be a green based on the 2 by 2, so this is 5. Now this is 3 shaded cells currently. It cannot be a 3, 4, 5, so this needs to be 3, 4, 5, 6, and 7. So this one goes all the way up. This is 7. This is a 5 shaded cell. This is 6. And that is the yin yang part. Now let's just add in the remaining digits. So the 9 can only be in this square up here. And square here. This square here. The 9 cannot see any of those. That needs to be here and here. Now we have all the 9s in at least. The 8 seen those squares. The 8 needs to go somewhere over here, which means it cannot be in any of those squares. 8 is here. And now the 8 needs to be in one of those two squares. Same with those two squares. So now we know it needs to be in one of these two squares. For the 7, has to be in one of those two, which means it cannot be anywhere here or here. It needs to be in one of those two squares, which means down 7. This one needs to be 7. This is an 8. 7 needs to be here. This is 7, 8 pair now. This one cannot be 7 anymore. This is a 1, 2 pair, but this one already sees the 2. What do we have here? 1, 4, and 6. So this is 6. This is 1 based on this one. This is the remaining 1. This one up here needs to be a 6. And then we have 1, 2, and 5. The 2 5s. The 2 over here is this 1, 2. 2 cannot be in any of those squares. Cannot be in any of those squares. Down here we have 1, 3, and 6, which means this is a 1. So up here is a 3, and this is 6. So we have 1, 2 here. And now 3, 4, 5. This one cannot be a 3 and a 5. This 4 and a 3, 5 pair. Now we have a 1 and a 4, which we cannot do anything with. This into 3, 4, 5, 7. Neither of those can be a 5. This is 4, 7, which means this one is a 7. This is a 4. Now we have the 7 over here. 8 and 7. And now this one needs to be an 8. 1 and 6. This one needs to be a 1. This is the 6. 1 and 4 up here. We already have the 4s. This 1, 4. Now this is a 2 and a 1. Now this digit needs to be a 1. And this is a 3, 5 pair. The 1 can only be here, which means we are only missing a 4. Up here we are missing a 3. And the 4 needs to be here, which gives us 3, 6, and 8. 8 needs to be here. And then 3, 6. This one needs to be the 3. This is the 6. Now the 3 goes over this square. 5 needs to be in the middle cell here. And then 2 and a 7. We have the 7. This is a 2 is a 7, and there we go. That was the solution to Through the Caverns.